All right. Sorry for a little bit of delay. I think I got signed out of like everything Twitch, and so I had to do a bunch of stuff this morning. All right. So where we left off, I actually got dewarp merged in. So I had prototyped that code a while ago, so it wasn't really that hard to bring it over. There are a bunch of bugs with it, but I'm not going to go down that rabbit hole just yet. I'm going to go upstream and fix some upstream image issues today. As a reminder, so this week I'm going to focus on doing everything I can to improve image quality, see if we can fix OCR, because again, in a lab environment, OCR works really well, but it's been not running well on the headset itself. So I'm going to see if I can solve that this week, and then hopefully one way or another, after this week, I'll go spend a week back in Godot, making improvements to the app itself, and then kind of do that, bounce back and forth between the two, until hopefully, at some point very, very soon, I stop having to spend a lot of time in C++ and can spend most of the time in Godot. So where we ended up with dewarping is there is a performance penalty to it. I think this is actually accurate to the headset as well. The headset's taking about 10 seconds to OCR, which, is a little bit worse than it was before. It's weird. Before it was, this score would report like 3 seconds here, and then on the headset it was like 8 seconds. This, I have it scoring around 10 seconds now with dewarping, and on the headset it's around 10 seconds. So that was one test though. Who knows? It might be worse. I'm not going to worry about improving speed at the moment. I just want to get the quality up. The scores were a little weird. Align frames, I think, got a little worse. This one got worse, but I'm like, this is the one that's like always going to be the hardest to get the score to go up on. So, you do a little bit of sharpening, crisping of the image, and all of a sudden this test gets worse as always. And then its time takes longer because its quality is worse, so it's bringing down the scores basically. And then Good though is interesting. Good was scoring around 80 before, and now it's up to 90. So dewarping made a big improvement there. And then Shaky even got it up to around 94 at one point with some tweaks that I undid because they made everybody worse. But yeah, this one is, I do feel confident that soon this one might be scoring like 95, which in my testing, I've observed once it gets to 95%, that's where it's like noticeably readable. Like, sure, there's some mistakes in the text, but it feels like readable text. So yeah, so I'm feeling pretty good about that. So this got merged. What we are going to do today is, I think we're going to, so book detection is something that might improve performance and quality. I guess, yeah, there's a number of things here. Let's go look at the notes. So we're going to do image quality in OpenCV. That's what we're working on today. So got the dewarp logic in. What we need to do, so there's two things I'm going to do. One is score images by quality. So I have some logic that I'm about to test. I already brought it in, that would give me a number score of an image by itself, just like scoring its sharpness, its crispness, doing a bunch of other tests on it. And I'm going to use that to see, like, I'm going to test that against the test suite in a second here. And if that works, then I'm going to test it on the headset. And in theory, if that does what I hope it could maybe do, that would mean that as we grab images from the headset, if the image is a little bit blurry, or if there's some motion blur from maybe the user's hands moved sharply while they were looking at the book, and so that image is just a garbage image, that we would get that as a score, and then we would know, don't bother OCRing that one, wait another 1/10 of a second, and then grab a frame that is a higher quality. So I'm curious to see, this may move the needle slightly. It could also be the reason why, if we look at the test scores here, you know, this one, why is this one scoring an 80 and why is this one scoring a 90? Or why is this one, which I thought was going to score worse than good? Good was supposed to be the high scoring one. Why is it scoring better? Maybe just the raw frames that I grabbed, the raw still frames I grabbed from the headset were accidentally better. And if that's true, then, you know, that's a hypothesis that I'm going to test today. If that's true, then maybe just being attentive to that quality score of an image by itself and just picking and choosing the frames that we try to OCR based on that, that alone, you know, one hypothesis would be that this doesn't change at all because this already has good quality frames. But maybe that would mean that like other test scenarios, well, not these because the images are hard-coded, but I could create another test scenario. I probably would add two. One where we've grabbed a bad one and one where we grabbed a good one. And we would see that, hey, like scenarios like this actually should be scoring, you know, maybe this one scores where it should be, and maybe this one just accidentally got a bad frame and it should be a 90, right? So I'm curious to see what this does for us. That's the one thing. And then the other thing would be fix cropping issues. And I think those are the two things that are going to dominate our efforts today. So what I mean by that is if we go look at this last one of these test cases that I ran from yesterday, you can see like this is like a mask that's being done as part of dewarping. And you can see that there's some like white around the border here, up top over here on the right. So we're not doing a good enough job of cropping, and that's affecting the dewarping, I think. Yeah, it's also just kind of... Yeah, like you can even get some stuff here. And then actually, no, you know what? Let me add one more item. Just so I don't forget about it, because I do think it is the next priority. We'll call dewarping bugs. So there are bugs with dewarping, and I'll show that right now. So if we look at... Here, let's look at what Tesseract sees. So you can see, like here, this word commitment gets scrunched, and the word partners here gets stretched. Fulfill. There you go. You can see with fulfill, it got really stretched. But then the next line got scrunched. And so it seems like it's doing this weird thing where, like, every other line is scrunched and every other line is stretched. And I know it... I went back to my original prototype code in Python because I knew it wasn't doing that before. And I was able to actually cause the same problem over on Python. And I think it's because if I give it a high quality image, so when I originally prototyped the code, I was using high res images taken from my camera, like from a phone camera. And those ones it doesn't do it to. So I suspect there's like a low quality image issue here where it struggles to dewarp properly. I don't know why that would be. So anyway, I'm going to dig into that. It could be just there's like not enough data for it to latch onto, that when it computes this mask of the characters, where it's detecting characters, that it... Yeah, I don't know. For some reason it's not finding them. And then also we still have the problem of things like, you know, the header gets picked up here and that actually causes some problems. So what I'd like to try to do is go early up in the pipeline, where even here, like we have, you know, we have this bounding box around things, but this bounding box is actually based off of these characters. So I guess it's trying to include that header there. So what I want to try to do is see if I can just like improve a crop that just gets a tight crop of just the text, and then kind of, yeah, and then go from there. Because if we can do a better job of isolating the text up here, then when we get lower, you know, we wouldn't have things like this up here in the upper right hand corner, or the spine of the book. And if those things aren't there, then when we get down to the mask, we don't have these extra artifacts here, and then I think we end up with a better final result. So anyway, that's a way of saying like that's where I'm going to go chase a bit today. But let's start with just image quality scoring, because if we can get slightly better images, then I'm just going to log out the scores here and see what we get for the frames. If we get slightly better frame scores, then that alone might go a long way to improving our ability to OCR. So let's run it. So I already have that code in. Actually, let's see why this is running, because that's going to take a moment. Let's take a look at it. I have this image quality score code. And it actually calls a bunch of different scores. Sharpness, motion blur, exposure, contrast. So I have all these functions up here that each like score it on each one of these things. And then we aggregate the score down. And I guess we, with some weighting. And then produce a score. So so again, we're gonna running against the test suite first. If this works, I'll probably put it into the headset, and then basically every time we do a tick of the engine. So where do we do that? On main GD, on process. Yeah, we call down to process in the scanner service. So every time we have a tick of the engine, we go tell the GD extension, the C++ code, the book scanner service. That's what it is. The OpenCV stuff. We tell it to go grab a new frame from the camera. So when we go and grab that frame, we can score it real quick and only keep it if it's a good quality one. All right, tests finished. Where are we at? Yep, 78 as expected. 11 seconds. Shouldn't be that bad. All right, let's go see what we see. Where are our frame scores? Oh, here we go. So this is our first test, which is... Sorry, align frames. So this one's the one that scores typically an 80. So they're all about the same. They're all about 0.6. Now let's go to our junkie test. What's our junkie test do? Interesting. 0.6-ish. Well, this one's junky not because of the quality of the images, but because we failed to align frames. And we all end up taking this one, which is a 0.6 by itself. So that's why that one scores terribly. Okay, but now the good one. Haha! So our good test, running test good, which scores pretty well, is scoring a 0.78. Noticeably higher than the other two tests. So this kind of affirms my theory so far. And then what about shaky, which is going to like make me a liar, right? It's going to tell me, making me a liar. Okay. 0.64, 0.63. Interesting. Interesting. Why is shaky so good? My one theory was that since I was shaking my leg while holding the book was moving in constant motion. Does somehow that mean that like the data between the different frames is different enough that when we align them, there's like extra noise, and because there's extra noise, that means there's a higher signal to noise ratio of like what's good data versus bad data when we merge the frames? I don't know. Whereas in theory, if these frames are too similar, if we end up with like two practically identical frames, then when you merge them, yeah, you get a little bit of denoising, but they don't really help each other. Or, is it blind luck? Okay, all the same, 0.63 was our low. 0.63. There is a world where we get higher quality frames. 0.63. 0.63. So to be fair, all the frames from shaky and good are higher than this first test scenario. You know, this one's best frame is as good as the worst frames from the other ones. So, is it possible that explains why this score is an 80 and these score 90? Maybe. The other thing is, let me take a look here. Why am I? It's like, why am I not getting the taskbar? Okay, so I had asked my AI to code this up for me. Now, when I did it originally, let's see here. Exposure, contrast. Well, let me see the details on each of these. So, sharpness. High variance is more detail in focus, so it's more sharp. Mild smoothing. Estimate noise in flat regions, simpler. Use blockwise, local variance. Okay. If you want to penalize high noise, invert or normalize appropriately. What are we doing with our noise score? Maybe I ripped that out. Did I? Yeah, I guess, you know, we don't really care about noise anyway, because noise gets kind of merged away, but check out the histogram is too clipped, under, overexposed, or has contrast. Motion blur, we might care about that more. Combine it into a quality score, yep. Implementation tips. Yeah. Okay. All right, that's performance things, which I don't really care about because it definitely is fast enough. So that's just a distraction. Adjustments given OCR, blah, blah, blah. Okay. You can still bake in heuristics to bias towards good OCR frames with prominent book. So sharpness, focus is important. Motion blur. So it's saying those three things: sharpness, motion blur, and exposure. Sharpness, motion blur, and exposure. Large texture region score. I'm thinking. Central mass heuristic. If you expect the book to often be near the center, compute the quality metric separately for the central crop compared to the global. Favor frames where the center is as good or better than the periphery. Example, adjusted weighting. Yeah, those are all the ones I applied. All right, I think what I'm gonna do is I want to do a full report. Before I go put this on the headset. Let me take this out and come down here. Sorry, I'm just getting my brain oriented. Let me sneakily have this coded up for me. Can you provoke? I have a log function I call that does special handling of logger messages. Can you craft a string report that I can pass to that function? Class name, message string. That I can pass to that function so I can see both the total score and detailed score for all the metrics. Yeah, that way I don't have to type this out myself because that's going to be really annoying. Yep, standard string report formatter, drop into your code. Okay, I don't need you to rewrite the whole thing. Yeah. It is kind of nice that he made it a function. Alright, fine. Yeah, you're right. Okay. I'll take it as is. Why not? I'll put it up here. Okay. And then I can just call it like that. And then do report. And in theory, that's going to work. Let's just build all. That way, if there's any issues with this code, because I didn't bring in that import intentionally. I'm not sure I need it. Oh, is there an acronym here? S-M-E-C-T. SMECT? Or... Stegum? Skempt? I don't know. There's got to be an acronym in there somewhere. The SKEMT report. The SMECT report. SMECT scoring. It's very close to SMART. 2 letters off. I think this is doing okay. I'm not going to look at this right now just because yeah, this can be too noisy. I really worry it's going to be. That's fine. Let's go with it. In fact, let's just run the tests and see what happens. I didn't do like a /n or anything. It's disappointing. Just a comma separated. Wonder if you can do like a /n. Should be able to. So if we go look at the top, what do we get? So we are always taking the middle frame. What is that motion blur score? Let's see. Motion blur score. Mean gradient magnitude, but like, how bad is bad there? Exposure 0.9, contrast, texture region. Now, that's fine. Actually, what we should see here, what'll be interesting actually is looking at this test, this bad one. So we should see, I should run this test by itself because that'll be interesting because we do end up with 3 different images. Ooh, yeah, that could be useful. Here, let me do that. We'll skip -K crop. And we'll run that test by itself. So what we have here is 3 frames. But you can see like this first one's decent. And the mistake I had made was I thought when it was capturing, you know, I held it up for a few seconds, but things were glitching. And so it was taking too long to grab a frame. And so I started putting the book down, even though I thought we were good. So we end up with distance drift here. So I wonder how it's going to score it. Oh, and actually, let me run it again. This time rebuild, see if we can get the new lines, then I can compare things a little better. Yep, there we go. So we end up with a... We can see this with the frames in view. There, that's fun. So the first one's the best one, and that one's in the center. It has the most sharpness. In fact, this one's got really bad sharpness. Do I see that playing out? I think so, right? Now we look at this. Those letters are pretty clear. And there is more blur here. Look at that word, consequences. If we go back one, here it's actually kind of readable. This one's not. And then if we go one more, also very, very blurry. Yeah, that's all a puddle of mush. This one's not as much of a puddle of mush over here. And then this one is downright clean. So that's bearing out so far. So sharpness seems to be pretty good there. Motion blur is 10, 10.9. No, does that mean no motion blur? Thank you. Help me understand the motion blur score. What does high versus low mean? Exposure, about flat for all of them. Contrast is about the same, I guess. And then text region are all identical. Literally identical. All right, let me just rerun the whole thing for all of them so I can see what the... There's a chance here that all I care about then is like sharpness and motion blur, maybe. I feel like that first one didn't have motion blur, but the other two did. Because I was moving the book, like I was in the process actually of... Actually, if we do the... Here are all the frames. You can see, like, I grabbed the first 3 for the test, but I did have 5 frames. You can see I'm in the process of taking the book and putting it down. So I had held it steady, thinking I got enough frames, and then I was literally in full motion of putting the book away. So that means these frames, the 1, 2, 3, these 4 frames were taken over the course of like a half second or so, or like a second or so. Whereas this one, things were still steady. So let's see if that matters anywhere else. So these all have the same sharpness. This one has the best score. I guess that's the game I can play, right? I can go to test cases and go see of these first 3 frames, do I see a difference between the best and the worst? So the worst one we'll put on the left, and the other one we'll put on the right. And we'll go in. Yeah, 236 seems good enough, right? Is it not going to let us? Can I not? Seriously? You're not going to let me? I hate Windows. Fine. Okay, so between these two images, sharpness is the same. I mean, this one's slightly sharper, ever so slightly sharper. Motion blur. This one has, it's sharper, but has a higher motion blur. Is higher motion blur good? This computes the mean gradient magnitude across the image, a measure of how strong and widespread the edges are. High score better. Low score weak. So less blurry with a high score. Oh, we're normalizing it? Interesting. Okay. So according to this, then, so this last one has less motion blur and is sharper. Exposure is the same. Contrast, same. Texture region is literally identical. All right, I don't know if there's enough meat here for me to see the difference visually. But it's saying the one on the right is better. I mean, I guess I can see it. If we see the word selling here, the S there has a little more blur on it. This one doesn't. I want to see it. I want to believe that I see it, but I don't. They look very similar to me. Okay, that's fine. What about another test? I'm not going to look at this one because I know that these frames are so different from each other. But this one has better sharpness. Actually, is that true? What were the sharpnesses up here? They're all the same. What does sharp mean then? So how are we normalizing those scores? What does normalize do? Simple min-max normalization utility. Produces a double. 50, 1500. So when I log the scores here, I'm logging the normalized version of them, which is not what I want. This doesn't help me, actually. I actually want SMECT. Because I want to see the actual values. I don't want to see the final score. It's annoying. And we're weighting these things. We're saying sharp and motion are both of higher importance, as they, they should be. So a fully blurry frame near 2 normalizes to 0. A sharp frame near 40 normalizes to 1. That makes sense. So, according to this, sharpness, I guess I gotta see. All right, okay, so it's going to normalize these things on a scale of 0 to 1. So when I see... That's why these numbers are going to look so tiny. But why would motion blur be a 1? Because if that's a... Because we're not... This is... Okay. This is not what the weighted... This is not what the weighting. This is just the normalized from on a scale of 0 to 1. Which means Tesseract, texture. We always score a 0.4. So we're always halfway between those two values, basically. We're always at the midpoint. All right, maybe it is fine to log those, the normalized numbers, because that makes it easier. If I see something like always hitting 1.0. Okay, so this means we're always around like 30%. That makes sense. For all of the metrics we've computed, I assume a higher score is better. Hence how we normalize and then compute the final score. Basically, think harder and double check your work. Higher score is better. This holds both for the raw metric value Yeah, we're not doing noise. I think we removed that. So, all right, so then back to this. Yeah, this is the crappy test. This first one's the best. It's got better sharpness. Motion blur has none. Interesting. Exposure, it's got like none. Contrast is about middle of the road. Okay, what about our good test? Not a huge variance here at all. So they're all going to be around the same. They're all pretty sharp. Yeah, because I just want to try to hold as steady as possible. With no motion blur. Very well exposed. Again, middle of the road contrast. And this texture region thing seems to always compute the same damn thing. Okay. And then let's look at the last one. Wait, 462, right? Again, this one also not enough variance for me to warrant looking at them independently. Motion blur, they all, so it really seems like sharpness is the thing that's mainly going to. But I guess that's good. I guess that means if we get some motion blur, we should tank the score. Which I think we got before, right? So these actually have a little bit, like they're a little bit lower. They're not 1.0 for the motion blur for this first test. The second test, almost perfect. For this one, I'm surprised there is no motion blur. All right, I don't know how much I want to really hound on this. Useful numbers, let me think. I guess I might as well deal with this one. Great. For this score, the scores are always returning .462. For all of my test cases. How can we tweak it to improve? I know you mentioned focusing on the center of the image, expecting the book to be there. I think that is a good idea. Other thoughts as well? All right. Threshold and block analysis are too coarse or not discriminative enough? They don't discriminate enough? Discriminative? Okay. Compute texture on a central crop. 60% of width and height. Yeah. That's probably true. fix the too flat output problem. It's still typing? It's typing slower. I wonder if they're doing that intentionally to like slow down the rate at which people call their API. Here's a cleaned up tuned version using all of the above. All right. What else do we have here? This always thresholds at 60 percentile. Doesn't vary much across images. The output will be nearly constant. Use an absolute gradient. Make sure the block size isn't too big or too small. We're using 64. Yeah, 64 seems big to me. Apply preprocessing to emphasize text edges. I'm not going to preprocess the image. What are we doing here? Used a fixed gradient threshold. Blocks. Block scoring. The center. Solo magnitude. All right. Let's give that a brief shot. If your block sizes are too big, you lose granularity and everything blends. That might be the case. Where are we calling it? Yeah, we're not overriding it, so let's run that again. Just to see if that just starts producing different scores, at least something. I mean, it really should. We have one test scenario where we very much should see different results. So if we look at this one, we have very different images here. So we should see different results. Where are we? Are we on that test? No, this is still the first test. We are seeing, oh, no, wait, hold on, 1, 1, 1, no, it's now all 1-0s. What about the second one? All perfect 1-0s. Okay, what if we do 32? So what's the speed on this? 27.1. Okay, so it's taking 1/10 of a second, maybe? Okay, that's fine. Let's run that again. No change on the first test. None on the second test either. If we go down to 8 for our block size, what does that do? In fact, let's just do the one test, because we know there's only one test that matters that we care about for this, instead of running the whole test suite over and over again. I mean, that's exactly why I would want to use this score, because it should catch this one scenario where the images are different enough from each other. That may have done something. The first one, it's high, 0.98, and then it drops off by the time we get to the third one. If we go 0.5, just go with the middle 50%, does that get more exaggerated? I wonder. I would hope that it does. That would be interesting too, because I do want to give the user the ability to like look away from the book and just sit for a moment in the environment that they're in. And so if they're looking around and they're not looking actively at the book, if the book is not in that middle 50% of their field of view, then we probably should kind of toss it away. And don't OCR, right? Just go into a holding pattern and wait. Nah, see, look at that. Yes, but no. I guess if we go middle 50%, like this drift, like it's still mostly there. %'s a little more conservative and probably better. I don't like it. I think it's not giving me what I need. But it does produce a little bit of signal, anecdotally. And it's something I can test for. So I think I'll keep it for now. And let's just get it on the headset. So how's that going to look? That is going to be... Right now we're calling it when we're doing some pre-processing on the frames. Where we're building out our frames. So I guess... All right, let's take that out there. Capturing queue image on process. So this is the thing we do every time. If we've enabled capturing and we make sure that enough time has passed, then we capture an image. That's a Godot image. I'm not doing anything with the score, so we can just leave it like that. And let's go back to where we're using it. Yeah, let me get this. So why would this ever be empty? We already do an empty check, right? Yeah, if it's not empty, I'm not doing this. Cut code. Why code things that you don't need? You know? Wait till you get an error, then fix the bug. Okay. That's our image, right? Okay, so now every time we grab a frame, we're going to take it, compute its score, and that's going to log it. So when I run this on the headset, let's build all. When I run this on the headset, that's going to tell us a bunch of metrics in real time that I should be able to see. In Godot, I want to probably turn off the HUD so I can watch it live myself on the screen. So I'm going to go project settings, and we'll go to our project settings. Oh, I already have debug off. Cool. We'll wait for the GD extension to build. I'll say deploying to the headset's been weird lately. It doesn't always attach to debugging. I don't know. It's weird. I don't know why. Hopefully it's not weird this morning. Here, let me uninstall it real quick and get the permissions ready. It's thinking. Every morning it does this. Take another sip. Wow, this is slow today. Usually isn't this bad. And the reason why I'm spending a lot of slow time on this one effort is the better quality I can get for the images up front, the effects will multiply. So it pays to really get better quality images as soon as possible. Okay, we're getting numbers. So that texture region thing. See, now I can't see because the... Wow, that is really clippy. Oh, because I am crushing this thing. All right, let's stop it. Yeesh. Okay. Just because we're doing tons of math on every single time, and that math is being done on the local thread of Godot instead of being done in the background. So that goes to show you, by doing these two operations here, that slows things down a lot. You can see how glitchy the experience was. Whereas all the other code I have here is happening in its own separate background thread by itself outside of Godot. And so by trying to do this on process on every single tick of the engine, ooh, it is hurting things. So that's where if I am going to do something where we only push an image onto the queue, what I probably would do is I would increase the queue size. Instead of 5, do like 20. And then what we would do is start from the top, start like when we go to collect frames, do it in the background thread and pop them off one by one, convert them, check their quality, and only use them. Use like the first, since I'm only doing 2 frames right now, I'm not even doing 3. So yeah, go find the first 3 sequential frames that have the highest score. Something like that. Or just above some sort of threshold, probably. I don't know. The 3 frames, the highest score, could be interesting. All right, let's see what we got. So things started running. Looks like our first frame was a non-frame. Can I see where we got starting OCR? So this is good, actually. This tells me when we started grabbing frames. So, So prior to this, if we look up here, we got like 0.7s, 0.7. I did look in briefly to get closer, so maybe like this one might have been that moment where I looked closer at the screen because I was trying to read. But we have like a 0.5. And then we at this point, we know we're OCRing. So actually, in theory, these last couple frames should have been all frames of actual book. I don't think I have a log statement for... How am I doing this? So I do have like the switch to AR check here in process. And then I tell it to resume scanning. So it's been paused scanning. So basically what I'm doing is the second... Okay. There probably should be a delay there. But the second I'm holding the book in the proper orientation, we immediately start to OCR. So there actually is no guarantee that these frames are any good. In fact, there's probably a higher chance that maybe they're not. Or like we're still in like a motion period where... yeah. When we resume scanning, we probably should wait a half of a second before we get going. In any case, 0.9, 0.8, 0.9. This one's 0.8. 0.9. Okay, so I'm going to say this is actually reliable now. Holy hell. So that means a texture region above 0.9 means we're probably holding a book. And if we go to the bottom here, we're back down to 0.7 when I finally killed things. It's not a strong signal, but does seem to me like above, like, you know, when we're in the 0.7 range, 0.7 bad. Well, that's the normalized score, right? .7. Interesting. How am I not... That's supposed to normalize... So if it's 0.8, that should normalize to 1, right? Oh, but we're doing it times 0.1. No, but we're not logging that. Gotta figure that out. So if I'm getting a 0.9, shouldn't... Oh, I'm sorry. This is saying... So a 0.9 is really like a 0.7. Gotcha. So this is actually pretty good then. Saying that... Got it. So if I wanted to stretch these out a bit, if I made this like 0.1, that'll actually stretch the numbers a bit and give us a little bit of daylight between like this 0.7 and the other number. Got it. Because this is the normalized score, not the actual. I could probably log both, right? So we could see it a little bit better. But yeah, I think this is like more like a 0.2. If we did that, that'll give us a little more daylight, and then we could factor it into the score a little better. But then what else are we seeing? So if we look at sharpness, 0.3s, 0.3, sharpness dropped there. This might have, I don't know, I might have been moving around a bit. Again, here is the first frame where I think there actually was a book. Definitely in the frame right here. Our sharpness is bad. Well, let's compare this one then to the ones above. Well, I mean, let's look at the overall score, shall we? 0.6. Yeah, forest for the trees. Let's take a look at the forest for a moment. We were looking at scores of when we ran the whole test suite. Let's run the whole test suite again. I think I was saying up to 0.7 was a good score. So here we've got 0.6s, which are supposed to be good scores. Dip, dip, more dipping. 0.4 is pretty low here. This is when the sharpness was bad. Huh. Why is this happening here? Oh, never mind. Because this is happening in the middle while we're OCRing. Yeah, it would have been nice to maybe actually score the 3 frames that we actually grabbed, but I didn't do that. So in theory, this 0.6 represents the first one. So actually, we have a string of like below 0.6. This 0.6 should be the one that an actual real frame that was worth scoring. And then at this point, I should be holding the book steady. And we had like a 0.62, 0.6, 0.6. So we're in the 6s pretty consistently. Here we dip. There we dip a lot. All right, next time I do it, I'm going to do another test in a minute. What I'll probably try to do is like really hold it steady. And what is our highest score? I guess if we were going to, well, I guess it might be premature then for me to go off of these scores. There's a bad OCR result. Yeah, we only got one OCR result. Okay. What do I do? How do I tune this? I guess is the question. Like, what is the right way to tune this? Because I'm seeing 0.6 and above is good. It's probably what we should be shooting for. Yeah, if I go back to the test results here. Oh, darn it. Alright, I think what I need to do, despite my best efforts, not do this here. Because that's going to cause everything to lag, and I'm not going to be able to see what's happening. Instead, what I should do is I should do it here. And then this way I can do like a couple of different scenarios. I can run through a couple of different scenarios. And even though it's going to be painful, I should turn this off. So let's not return early with the top text. Let's just wait for the whole thing to finish. Yeah. And then let's run the test suite real quick just to make sure this is working. It's going to be slow, but I think I need to do it to test. So anyway, the point being with this, if we look at the test reports. So on our first test, we get a good texture rectangle. Second test, see, the second test says we don't. Wonder if I can stretch that a little bit more. Here, let's go crazy. What if we go 0.4? And let's run that on. Yeah, let's just run on K, on like the uncrop. If we look at that test in isolation, like I want to see if I can tune this texture test, the large texture region. Shouldn't that be text region? Let's call it text region. So if I do that, there we go. So this is getting a not like this is getting close to 100%, which is pretty good. This one's scoring quite a bit lower. So in fact, I'm going to go to 0.5 on this. And oh, by the way, it is affecting the quality score now. So now the score is actually dipping because of that. So let's exasperate that score a bit. And if I use that as part of the criteria for scoring, for determining what frames we use, I wonder if then... I mean, I guess in this case we're using this middle frame, which is a good one. You know, it is kind of funny. Why are we doing that badly on aligning? I guess like that big enough of a jolt is enough for it to be thrown off. Let me double check that. Yeah, why are these 3 frames those 3 frames? This one and then the hands are both down at the bottom here. That doesn't seem right. Oh, I think I know why. Right, because we're taking the middle 3 frames. We're not taking this first one. Because instead of taking 5 frames, we're taking the middle 3 from the list. We're dropping the front and back and taking the middle 3. So then this becomes the middle frame. So if I wanted to cheat and bake the scores, if I brought these 2 in, these may align. And if they align, then immediately the score goes up. But I actually don't want that. I want to try to align this frame with this one, which is theoretically possible, right? It should be able to theoretically align those 2 frames. And even this one, right? This one's like kind of over a bit, like, and if this is the, in fact, this is the middle frame. So it should be able to like bring this one closer to that and then bring this one closer to that. And in theory, it's theoretically possible to merge the data between these 3 frames and get a good score. So that's why I'm keeping this test case as it is. Okay, but that means this one, the first one should have the highest score. And now we're getting some real distinction here. Because now this one's getting a 0.6. And that's really pushing that score down. Because we're getting that region. Okay, so that's actually working. That's cool. Okay, now what about... Well, let's look at the middle 3. Sharpness-wise... So this one's very blurry. This one's better. That one's pretty good. I'll bet you if we score this frame, like I think this is the one that we run through OCR. If we were to just choose and select this frame instead, things would be a lot better. So sharpness-wise, it is scoring better. What did we see in Godot? So our minimum sharpness... 0.3, 0.3, 0.2, 0.3, 0.1, 0.2. I don't think we ever get a higher sharpness. 0.1. 0.07. Okay, so that means the floor... I should leave the floor where it is for sharpness. But the ceiling, I should bring the ceiling down a little bit. If I do 1,000 now, Let's run that test again. So now what that's saying is you don't have to have as high of a sharp score. And the thing is, we're not dealing with still images taken from a high quality camera. We're dealing with still images pulled from a video feed. So they're never going to be as sharp. So if I lower my criteria for what's considered good sharpness, we should get a little, again, we're trying to like stretch things, right? We're trying to get to a place, like we don't want to see scores of 1.0 and we don't want to see scores of 0. What we want to see is things stretching from 0 to 1 as much as possible. Like, I guess nothing should get to 0 or 1, right? We should see some like 0.25s and we should see some 0.75s would be the ideal. And if that's true, if we're seeing a good gambit of things, then by normalizing properly based on like the data that we have, then when we multiply it by importance, we should get a more meaningful score. Instead of having to split hairs and be like, oh, well, a score of 0.5 isn't good, but a score of 0.6 is good for the final score that we get. That's not great. What we want to be able to see is like a much more distinction, a better distinction there in the scoring, which we're not getting right now. Here we go. So this is getting like a 0.8, and this is getting a 0.6. So now our sharpness is 0.5, 0.3, 0.2. And I am seeing that. If I go look at this one, like it's pretty bad. Motion blur, we're getting a 1, score of 1. So actually, I think motion blur, I should take that up to 60. And let's just run the whole test suite now. Let me tweak these numbers a bit. Now that I have I've played with the data a little bit and I've got a good feeling for the data, let me mess with these things. And if I can get some things to discriminate a little better, then what we maybe should see when I run the next test is that instead of everything floating around like 0.5 and occasionally dipping lower and occasionally, you know, scoring a bit better, I want to see, I want to see a lot more difference in here. I want to see like a bad image. Yeah, these are all like 0.6s. Like those are pretty good. Like actually no, because like when we, again, ignoring this first one, I can tell you right now, these ones didn't have a book in hand. There was no book to scan. Number one. And also I was opening the book at the time and I was moving my hands. Like there should be some more motion blur. In fact, we're even seeing like the fact that this isn't a 1.0. Like this one's probably pretty bad. The 0.8. Here we go, 0.6. So this one right here, I may have been in the middle of like opening the book at this moment. So we want to exaggerate these numbers a little bit because I want to see a number like this go down to like 0.2. And a good number, I don't even know what our highest number was. Should go higher. Yeah, anyway. All right, what are we seeing with those changes? So our first test, sharpness is still around middle of the road. That didn't change at all. Motion blur, we're now seeing actually more middle of the road numbers there. By the way, exposure, interesting. And then texture rect, I mean, again, these were, I mean, I would expect for most of our tests scenarios that the scores should be fairly similar. I mean, I think for a lot of them, I visually can't see a difference between the images. So, but that's because these are 3 frames all captured together at the same time when I'm trying to hold the book steady. So I would expect them to largely have similar scores. So exposure might need to be dropped down a bit. Exposure scores are getting too high. So, I don't know. Let's go 8.5 on that. Yeah, I guess if it's getting too close to one extreme or the other, you increase or decrease the number that way. Or if things are too tight, if like everything is always like if all the numbers are always around like 0.5 together, then you could scrunch the scores. So for instance, on motion blur, if they're all always scoring around 0.5, 0.6, then that would mean we should bring these numbers together, probably raise the floor. So then that way, yeah, we're seeing a bit more of a distance between them. Yeah, okay. So then this one, again, we're 0.7, 0.5, so we're actually seeing some distance here, and we know that this frame is a much better one than this one. So 0.5, again, 0.6, 0.6. So motion blur, again, motion blur not good enough. I'm going to raise that to 10 and see if that helps us. This test especially, I should see some wild swings. Like, there actually should be a big difference between this score and that score. I think that's what I'm realizing. This test is turning out to be a great test right now. And then with our Tesseract, we got a great one here and a bad one there, which is really what the main score difference is between the two. Yeah, exposure 1.0. Okay, we know this. Sharpness is 1.0. So it's like perfectly sharp. Interesting. And what about this last one? So that is interesting. So maybe then shaky, where I expected to not to have a little bit of motion blur and things. What are these, like 0.8s it's getting on motion blur? How does that compare? 0.9. So it has a little bit more motion blur. This is sharper. Less sharp. Okay. Let me run again. I made a couple tweaks. Again, I really just want to see normalized numbers be a little bit more distinct, especially in that second test case. And if I'm getting that, then the only other thing to do then might be to tweak these a little bit. But actually, I think these are probably pretty good. I just need enough signal where I can tell that one image is objectively better than another image. And if that's true, then we can select. Before we OCR, select for the good ones. This is feeling promising to me. All right, what do we got? 0.6, 0.6. See, this is kind of flattening out a bit. Maybe that's a good thing. Ooh, this is flattening out a bit as well. Why is that? This one's scoring well there, but low there. I think that's good. %, sharpness. So I think sharpness. I think I need to raise the ceiling on sharpness a bit. And then what about these other ones? Sharpness is getting around to about 0.2. Let's go 100 on that. I want to see this one get pulled down. And then blur. How is blur doing across all these tests? 0.5s. 0.6s. 0.8s. 0.8s. Okay. So 0.5 to 0.8. Let's try that again. Oops, that was loud. Let me push the spent coffee away and switch to water. All right, time check. How are we doing? Bit slower and more tedious in this stream, but it's all goodness. All right, how's our first test scenario looking? Well, our scores dropped quite a bit. Not very sharp, it's saying. Is that true? Does that first test case not have sharpness? Let me do, how do I change this? Oh, group by type. There we go. That was annoying. So it's saying none of these are really sharp. I wish it would keep the same zoom when you flip between them. You know, to be fair, there's a good amount of movement here. Hold on. So it's not the 0 with 1, it's the middle 3. 1, 2, 3. Yeah, there's a good amount of movement there. Maybe that's why... Well, that's why this test case is called aligned frames, because I knew I was having alignment issues. I fixed those alignment issues. But okay, our motion blur is pretty low now. It's a lower scoring test. And nothing's terribly high scoring other than the Tesseract being center and prominent. Which should be true for all of them. And then this one, again, we know the first one's vastly better than the others. Now we come to the good test. Sharpness is still perfect. I don't like seeing that. So what do we have here? 0.4s, 0.2s, 0.3s, 0.4s, Okay, maybe I have to go up to 1400 then. Maybe that should be that high. And then we're seeing some pretty low numbers on sharpness then. So I guess sharpness does run the gambit of 0.20. Okay, motion blur I also changed. So let's see here. Sharpness is, well, I'm looking at the sharpness still, 0.6s, so medium sharpness. These are 1.0. So this good test does have sharper images. Now what about motion? This first test has low motion scores, so the motion's pretty bad. The second test, also pretty bad. Third test, pretty good. So the good scenario is at about 0.8, which is what I want to see. 0.7s. So I think this is good now. I'm seeing 0.8s, but I'm also seeing, right, 0.8s effectively, but I'm also seeing 0.2s. So I think this is well calibrated. This one might be close to being well calibrated. Exposure, I know I tweaked. Where's that at? 0.7s. 0.7s. 0.6s. 0.6s. So this might not add any value at all. Exposure. 0.6s, 0.7s. I did raise this, right? Let me go 8.0 and 5. See if I can just get a little bit more. I get the feeling this should be scoring lower and this should be scoring higher now. And then contrast. How's contrast doing? Point 0.5. 0.5. 0.5. Like 0.4, 0.5. 0.2. Okay, let's drop that down. And then texture is great. So I think we are getting close to that. Also, okay, so while that runs, can I produce a score? How was I doing this? On Godot, I would run the test suite and then get our score, right? Score is compute text similarity. And I think that is in here, right? Okay. Actually, I can do this whenever. Yeah, let's do that. So, game state. Let me go look at the logs. I might as well do it here. Yeah, that'll tell me something. So, add page. Sure. Oh, here we go. Right. So I already had this here. There we go. So I'm going to do new page. Yeah, page text. Okay. Let me turn this off for now and bring that over. So we'll always just set the page text because we're just testing right now. And we'll log the similarity score, which will help things. Okay, I think I'm ready for another round of testing on the headset then. Annoying that we've now normalized the scores back down quite a bit. Well, actually, no, this is the first test. Maybe it should be. Second test. Yeah, this one's kind of funny that these scores have now normalized when really they shouldn't be. This first one. I mean, the sharpness is higher. I think we can just weight the text region higher. I mean, that for this test scenario anyway, that's what would really set the score differently. But I guess what are the differences between the tests? So we got like 0.4, 0.5 here. 0.5 up here. And then down here, how are we scoring? 0.8s. Okay. Interesting. So even here, like just the individual frames are worse. Same thing with here. Just the individual frame quality is worse than the good test, which is scoring up now around 0.8. We finally got sharpness not to be perfect. I think we succeeded. Texture region got a 1.0. How'd that happen? That shouldn't happen. For the good test, it got a 1.0 on that score. Group by type. Close those. I mean, actually, you know, maybe it should be, because this, I held it very close. I tried holding it close to the camera, and we are looking at the 60% or 60%, and it's scoring like a 1.0. So you know what? That probably should be about a 1.0. Fine, let me go 0.9 on that, because I don't want to give it, I don't want anything to have a perfect score. But maybe that should be. And then down here, 0.6s. 0.95s. Yeah, so we're getting close there. All right, I think I'm getting pretty happy with this. So then I think it's just a weighting question. And I already have some ideas on weights. What's interesting then is, so these first two struggled OCR. Maybe they should. But these last two are both scoring 90s. This is a 0.6. This top test is about 0.5. 0.5. And this one, which scores a 0.6, is getting a higher score than everybody else, even though we have another test that's scoring 0.8 on image quality. So why is that? I mean, all of its scores are lower. Sharpness is around 0.5. Motion blurs lower as well. Exposure, we got 0.6 here. Same. Contrast, 0.64. Contrast is lower. Texture region's perfect. I think I fixed that. Texture region's perfect. So, on all scores, the quality of these frames is better. And that probably should be the case. That was the intent. So, actually, Well, I guess what is interesting is the shadow. I wonder if the shadow is what did it. 1, 2, 3. So we have to resolve this, but the shadow only affects page 2. And all my scoring is done on just page 1 of text. Either way, it's like a well-held, well-lit scene. Meanwhile, if we go to our shaky test case, there's actually more shadow here. And a little more movement. Okay, so I guess to some extent, image quality isn't everything, right? That's kind of the lesson there. Whoa, what is that? Page text on nil. How is that possible? That shouldn't be happening. This feels like a glitch. Oh, page text isn't a thing anymore? So, OCR page. No, we have page text. That's not what it's saying. It's saying it's on base nil. Oh. That's not what I want to be doing. I want to be doing reference text. Where is reference text? Right. That's why it's erroring. So page 1 could be nil. I'll just do it the same way we do it for the test suite. And then reference text is... Where's that from? From this. It's all from the tests. Okay, fine. Fine. Here's what I'll do. I'll bring over this code temporarily. All right, fine. Should be able to do this. I think. And then test case dir, where are you? expected test results. Is a dictionary. And then I guess we're just going to load it once, right? Darn it. Okay, this is getting stupid. Hold on, taking a break to block somebody. Let's see here. I'm overcomplicating this. So we'll hard code that. Parse JSON not found. Oh, yeesh. So I gotta bring that into. Okay, fine. I'll rip out all this code later. It's fine. Arguments. Wait. I don't need parse args. I need parse JSON. Oh, that's dumb. Why do I have that as a function? Okay, there we go. So, we load the test case. We then, we just go to the testing dir, open the file, get its contents, parse it. Then we iterate over it. We load each of those files. File name in. You know what? I mean, I could gut this, but I don't know if I care that much. We then go get its contents. We add those to the dictionary, but then at the end of the day, I'm just grabbing just the one, just to get our reference text. Roundabout way of having our reference text for a similarity comparison. Okay. Right. Let's run the test suite again. This time it shouldn't fail. All of these test scenarios are the same test scenario anyway. I guess we'll display two scores, right? All right, let's take a look. I'm not making any more tweaks to this for the moment because it should be good enough. Page similarity is 0. Why is it 0? All right, let's cut it down and get that in because I need that comparison, I feel like. So we're opening the file. we're getting its text. And we're doing expected so in theory I should be able to just do that. Expected OCR result is set where? We're never setting that. Okay, in theory that's... Wait, hold on. I don't need that. Okay. Let's just gut this down. So we're literally going to do... I think it's just the content. Okay, so I think I can just do this. And then gut all this. And now maybe it's as simple as that for what I'm trying to do right now. Did that work? Still 0. So it's not finding the folder. Why is it not finding the folder? Testing, test cases. Yeah, it's just a block of text. Why is that not working? Testing, test cases. I'm gonna guess this is never called then. That's really the issue. Fine. If not, reference text. Load it. It's the hack solution. Skip building, because we don't need to build the back end anymore. We're just working in Godot for the moment. There we are. There's our score. Great. And then the last thing I'll probably do is... Yeah, where's that score? Yeah, individual results. Let me bring that in. There we are. Right. And then I'll just do run one of them again real quick just to make sure, and then deploy it to the headset. And I'm displaying it up here. There we go. Cool. /build -all. I don't need to build Windows. I could have just done Android, but that's fine. And then where is our... Come on, build. I guess I'll wait for Windows. Just on. Actually, no, I'm not gonna wait. Shouldn't matter. Godot 4.5 Beta 5 is out. With bug fixes. I wonder if they fixed the one bug I ran into when I tried to upgrade. I don't want to test it just yet, but they are moving very quick, which tells me the next release of Godot is probably got to be maybe at most a month away. I was gonna say, I was like, what? I thought what happened to the thing? Okay. Let's see. Okay, there we go. Oh, and let me turn on better lighting in the room. Let's give ourselves the best shot at OCRing something. Oh, by the way, why is it doing that? Oh, you're probably not even seeing what I'm seeing because I'm not casting, am I? Completely forgot to do that. Might as well do it now. There we go. Okay. So we're only going to do something. Oh, see, we're already OCRing. Okay, so this is OCRing garbage. I'm going to hold this up and hold it steady. Now we're OCRing again. Why is the text not changing? I probably broke something. Oh, because we're OCRing the entire... I forgot. So we're OCRing the entire page, which is going to take 30 seconds or so at least, instead of waiting. Well, I'm going to hold my hand here steady so we can get a nice, good OCR event. So this first one should be garbage. But also, that's the reason why I wanted to get that score working, so I can objectively tell that in the numbers. So then we can compare OCR numbers in the real world to image quality in the real world. Seriously, what's going on? Is it Okay, so it's getting OCR results right now. Still. I crash app? Is that what happened? Yes. Broke something. Great. Game state 21 get as text on a null value. God damn it. So it can't find the file. Because on the headset, do we just not have it? That's probably why. Killing me. Fine. I'll do this the way I probably should have done it since it's temporary code anyway. Copy the text. And do that. And then do that. Now let's try it again. So the hope I'm looking for here is to get good scores and bad scores of OCR text and see if I can, in the numbers, determine like what factors affected that quality and then adjust the weighting for those on those factors. Maybe even drop one or two of the settings if they just seem to have no impact. And then incorporate that scoring into how we choose what frames should be processed for OCR. So that way if I'm getting bad frames, we just don't even bother to OCR. No, see, that probably went too fast. Yeah, OCR failed to load. I hate when it does that. Let's run it again. The headset will probably go to sleep in a second, which is what we kind of need. I may be able to do this. I keep trying to set up a test rig where I don't have to use my hands, but yeah, it's not going to work, especially with hand tracking. In the test rig, I can never quite hold the book flat. I guess what I should have done is do like plexiglass with some hard backing and then clamp. And that could have been a test harness for holding a book steady. But I don't need that anymore because I'm looking for more natural testing. Okay, hopefully this will work this time. Oh, it's not going to work. I know it's not going to work. Yeah, see, it's already going too quick. I need to stop casting. That's the problem. That's annoying. All right, let's uninstall again one more time. Let's try this. Maybe the headset will go to sleep. And then it'll work. The other approach I could take is to stop caring about debug connection to Godot, which gets broken. That's the reason why I don't like this, is because it breaks. And I could just logcat with ADB and just do it that way. Then I don't have to worry about this back and forth like I'm doing. That's probably what I should do. I guess I just like seeing the logs in Godot, but I'm not actually doing... Yeah, I'm not actually doing anything with them, so fine. Let's save ourselves a little bit of pain. Where is our logcat? let's do it as a new shell window. Let's do pipe grep Godot. Okay. And then, well, while that's running, actually, I should be able to now cast without issue. And the worst thing I'll probably have to do is just restart the app. And then that would be it. We would be able to just log from there. But see, we're not going to get... I'm going to have to quit and then go to unknown sources and relaunch it. And now it should work. But are we going to get the logs I need? Hold on. No, we're not going to get the logs I need. If I just do them all, okay, hold on. What are the logs I need? Oh, I need to, but see, those are Godot logs. Let me drag this back over so you get a nice crisp view. Actually, we can do this with... What? We can't share with the casting? Fine. Pipe grep Godot. Not good enough, unfortunately. It's fine, Godot. Okay. Let's try this again. In fact, I'll do clear, and then we'll do... Can I clear these? No, I can't. I can't do anything now. Okay, fine. Let's go with that. So this first one's still probably going to be pretty bad. But let me get a nice close. There, out of the corner of my eye, I can see that we're getting OCR results. Actually, I'll know it succeeds because I'll see good results up there. There we go. It's not the best results, but the next round should be better results. So now, while I'm waiting on those better results to come in, I'll hold it at like arm's length a little bit and see if we get, not necessarily arm's length, but you know, a little further away, and see what we get there. Yeah, so there's the better version. Oh, why is that? That is messed up. To be truly sales driven is at the bottom. That is not what should be happening. Weird. But I wonder what I'm going to get in a moment. I'll go medium distance as well. Come on. Just one more. Unless it broke for some reason, which I don't think it would have. This feels like it's taking forever, but it shouldn't be. It should only be about 30 seconds or so, I think. Maybe it broke? I can't see with the headset on. No, it's still going. Yeah, we'll go one more. Now that I'm holding the headset in my hand. Just because I want to see one more. Come on. Wow, that is slow. Why is that so slow? I don't remember seeing it this bad. My hand is getting tired. I may call it quits here. Fine, I'll call quits. You know what? Ugh. So what do we get log-wise? Where is our... Okay, I'll wait for this last one to come in. And then I'll kill it. And then just go look at the logs. I'm not going to run another test just because it's too tedious and annoying. But that last score... I don't know. Let's just give this a moment. Although in this case, this last one could be a good little test because I'll at least get those quick image scores of like the headset is sitting on the table, not moving at all. And it's not pointing at a book. It's pointing at like a screen. No, I killed it too early. I don't think I gave it time to grab another one. Okay, let's take a look. All right, this is all the permission error stuff. Well. Okay, permission error stuff. Scores of 0.5 and low texture rec scores. And we got gibberish. So I'm really liking this texture region scoring. Terrible page similarity, of course. But, you know, good exposure and contrast. It's probably because of the lighting. So maybe I do need these, if for no other reason than to alert the user that, hey, maybe you're, you know, if these scores come back low, then that's like, hey, your lighting is probably bad. Maybe. It's probably true. So then we started OCRing again. At this point, I think I had a good handle on it. I had it in hand. No text regions detected. I think I short-circuited. Again, 0.2, 0.1. So there was no book in hand for this one. I think we ended early. Okay, then we ran again. Low score. Not much of a texture rectangle. I think maybe it wasn't quite ready. Like we had it in our hands, but not quite. .6s. So we got a pretty decent, other than the texture region being bad. I guess we had a bad texture region, but the book was there. I don't know. So then we ran again. This time actually like okay scores for texture region. Is that proper text from the page? Yeah. That's a couple lines down from the top. This is the start of like a paragraph towards the bottom. So maybe the book wasn't centered. Scored 80 though. Why is that scoring an 80? That seems like a score shouldn't be that good. I guess we did OCR some sentences pretty well though. This one equally bad on texture region. But again, the text is bad. And that was it. This doesn't feel like it was a good test to me. These scores were like 0.65. And we did bad. Well, I guess we can look at that, right? These scores were worse and we did better. So what was the difference? I mean, other than the text rect. So texture rectangle here was better. Well, I keep saying text rect because that's an OpenCV function you can call. Texture the region that we saw. 0.5. Down here, also around 0.5. Sharpness 0.7. Worse sharpness. So what's scored well then? Motion blur is 0.6. Motion blur is 0.5, so slightly less motion blur. Exposure is 0.5-ish. 0.8-ish. Higher contrast, 0.8. Lower contrast. So, what the hell? So this one scored better and did worse on OCR. All right, well, I think I need to take a step back and think about it then. And see, like, what about this is... Also, I need to grab lunch and go do some other things. So I think I'm out of time for this. Definitely didn't get to all the things I wanted to do today. Where's my mouse? Let's take a look at that. Let me remind myself what I was trying to do. So score images by quality, and then, oh yeah, go try to fix the cropping issues and the de-warping bug. Yeah, I mean, it is possible that these two issues are getting in the way of me properly measuring the score. Let me take one more quick look at this. Point sixes. Point fives. Point sixes. Point fives again. This is the best one. We never got a good one. Okay, so I'm thinking... All right, that's going to be my leading theory for now. So what I'll probably do, what I probably think I need to do, is I'll take this scoring, and I'm going to call it a success. I'm going to put it up in a pull request, but then undo the code change for it. Like, you know, basically, go back to the main branch and just shove it off in a corner. I think this will help things. But what I think I need to do first is, again, go fix our cropping at a minimum. And maybe even go fix our de-warping. If I improve these qualities here, I'll get slightly better scores. Or, like, less error when it comes to scoring. And then I can then rerun this quality scoring. And then that way, then something like this, I don't know, we would get a better result. And it would be easier for me to see what affected it. And maybe I could set up a tighter test scenario too. I don't know. Okay, well, anyway, thanks for hanging out with me, and we will chat soon.